Welcome to Prajim Technologies. I am Venkat. This is part 43, Exception Handling Abuse. In this session, we'll learn what exception handling abuse is all about, and we'll also see how to prevent exception handling abuse. Now, we know that an exception is nothing but an unforeseen error that occurs when a program is running. For example, let's say we have an application that reads data from a database and displays that maybe on a web page. And when it's doing that, there is a database error. So obviously to handle that we use exception handling techniques. But many a times I have seen people using exception handling incorrectly to implement the program logical flaw, which is extremely bad, and that's what is termed as exception handling abuse. Probably we'll look at an example which will make that clear. So let's say, I want to write a simple program which can divide two numbers and display the division result. And that's pretty simple to do. So first let's prompt the user to enter their numerator. So console.writeLine, and we'll ask the user to enter numerator. So please enter numerator. Now, once we ask the user to enter the numerator, he will enter the numerator. So we need a variable which can hold that. So we use the console.readLine method to read the input from the user. But since readLine reads that in the form of a string, we need to convert that to integer. So we can make use of convert class. So convert.toInt32. So what is this going to do? It's going to convert that to integer and store in that numerator variable. So similarly, let's ask the user to enter denominator, and once the user enters the denominator, we want to read that from the console, convert that to integer, and store it in this denominator variable. And obviously we want to calculate the division result, which is equal to numerator by denominator. And then we finally print the result back to the user. So result is equal to result. Alright, now if we run this program, it's pretty simple. It will ask the user to enter two numbers. Let's say numerator is 10, denominator is 2, result is 5. It works. But then there are several reasons why this program can fail. If you look at this, it's asking us to enter a numerator. The first reason why this program might fail, if I enter, alphabets instead of numbers, what this program will do, it will try to read that from console and try to convert that. Now, when this convert.toInt32 method, tries to convert the string, it cannot convert that to integer. It will throw an exception, format exception. So when I do this, look at that, you get a format exception. So obviously, to handle that, what we can do, we can put this in a try block. So basically what you want your program to do is, you know, when you read that input from the console, you want to check if that is in a valid format rather than using exception handling like this. So for example, format exception, let's say FE, and what we do, console.writeLine, please enter a number or only numbers allowed, whatever. Okay, we don't have to use this object here because we are not using that for any purpose. So now if I run this, so please enter numerator. So if I enter alphabets, then what's going to happen? This line will try to read that, convert that to integer, which will fail. A format exception will be thrown. The catch block will catch that exception and prints this message to the user. Okay, that looks fine. But there are other reasons as well why this program can fail. For example, it's asking me to enter a numerator. Now I enter a very big number. Now you know that an int32, an integer, can only hold a number of certain size, and this is definitely big for an integer able to hold. So when I press enter, what's going to happen? Console.readLine will read that number, and when it tries to convert that to an integer, obviously it cannot convert that to an integer because it overflows. Okay, what happens if you pour 2 liters of water in a 1 liter can? It's going to overflow. Similarly, if you try to store a huge number in a variable of smaller data type, obviously that's going to overflow. So we get an overflow exception. So obviously to handle this, probably we have to have another catch block, maybe catch overflow exception. And what we want to do here is we want to tell the user, okay, you entered a number that makes sense, but that entered number should be between, the ranges that an integer variable can hold. And what is that range? How do we find out? Let's see that. So console.writeLine, and then we want to say only numbers between, that's the minimum value, and maximum value are allowed. So what is the minimum value that an N32 variable can hold? It's very easy to identify that, to find that out. You don't have to remember, on top of your head. So for example, if I say that int32, we know that int32 is a value type and it's a structure. So the IntelliSense shows that. So now when I right click on that and say go to definition, look at this. This int32 has a constant, a public constant variable of minimum value and maximum value, which will basically tell minimum value it can hold and what's the maximum value it can hold. Basically, you can use these two constants to get your value. So minimum value and int32 dot max value. So that's it. So now if we run this, and then if we try to enter a very big number which an integer variable cannot hold, obviously it will throw an overflow exception. This catch block handles that and then shows this meaningful message to the user. So only numbers between that range are allowed. And there is another reason why this program can fail as well. Let's see. Now, please enter a numerator. I enter a valid number. Please enter a denominator. I enter 0. Now we know that in mathematics it's illegal to divide a number by 0, which will lead to infinity, and a program cannot withstand that number. So obviously dividing by 0 is illegal. So the application throws divide by 0 exception, but our application cannot handle that exception. So when we do that, we get a divide by 0 exception. So obviously to handle that, we need another catch block, let's say. So catch divide by 0 exception. And obviously what we can display here is denominator cannot be 0. So we'll display that meaningful message to the user. Denominator cannot be 0. So now if the user enters 0 as the denominator, then he will get meaningful message. And apart from these three, if there is any other exception, then it's safe to have an catch block. So we will just say console writeLine ex.. Maybe here we will have a reference variable. All right. So now our program, okay, it can basically tell any type of exception. Now I run this. Is the case, program doesn't break. But then if you look at the we have done in this program, this is actually wrong. I mean, we are abusing handling. Instead of using format exception overflow by 0 exception to handle those, okay, I would use error checking mechanism using convert.to to use int.tryparse method. If the tryparse is not successful, you know that there is something. Based on that, use messages. Similarly, instead of allowing the by 0 exception to occur and then catching that, what you can basically do is check if the denominator is 0 after you have successfully parsed that, and then show that message to the user. All right, what we will do is actually we will see how to prevent this exception handling abuse with an example in a next session. So I hope in this session you have understood this way of implementing programming logic. Here what am I doing? I'm using format exception basically to tell, okay, your entered number should only be a your entered value should only be a number. And similarly, to tell him the range, I'm using overflow exception. But instead of that, once you try to parse that based on the result, you can basically tell whether if he has entered a number or not, whether if it falls within a specific range or not. Similarly, if the denominator is 0, you can straight away tell the user, okay, dividing by 0 is not allowed, rather than allowing the divide by 0 exception to occur and then telling the user, within that exception block, okay, denominator cannot be 0. So we have to prevent this, and we will see that in our next session. On this slide, you can see ASP.NET and C# interview questions. Thank you for listening. Have a great day.